In this video, we're going to look at the concept of Le Chatelier's principle for chemistry. Now, guys, this is an important principle under chemical equilibrium for chemistry. So ensure you stay to the very end of this video and understand what this principle is talking about. Alright, so we are looking at the concept of Le Chatelier's principle. Okay, principle. Now, note that Le Chatelier's principle is used to predict the effect of any change you make to a reaction system. Basically, what is Le Chatelier's principle? Le Chatelier's principle states that when a system in equilibrium is affected by some factors such as temperature, pressure, or concentration, alright, the system will adjust itself in order to cancel or annul the effect of change. Now, let's look at the effect of temperature on the Chatelier principle. Let's look at how temperature will cause a system in equilibrium to adjust in order to cancel or annul the effect of change on the system. So let's use this example. We're going to use nitrogen molecule here with hydrogen molecule to give ammonia. As usual, this sign shows that this reaction is reversible. Very important, guys. Now, note that in the question for chemistry, if they are asking you to predict the effect of change on a reaction system using temperature factor, they're going to indicate if the reaction is either endothermic or exothermic at the forward reaction. So for this example I'm using, the forward reaction is exothermic. So let's predict the effect of change on this equilibrium system or system in equilibrium. Now, since the forward reaction is exothermic, now note that when the forward reaction is exothermic, the equilibrium position will shift from the right to the left, favoring the backward reaction when there is an increase in temperature where the forward reaction is exothermic. Okay, whereas when there is a decrease in temperature where the forward reaction is exothermic, the equilibrium position will shift from the left to the right, favoring the forward reaction. So take note of the change occurring. Whereas when the forward reaction is endothermic, the equilibrium position, an increase in temperature when the forward reaction is endothermic, an increase in temperature will cause the equilibrium position to shift from the left to the right, favoring the forward reaction, whereas a decrease in temperature will cause the equilibrium position to shift from the right to the left, favoring the backward reaction. So take note of this change effect on temperature factor. Okay, so let's look at pressure factor now. Let's wipe this. Okay, so for the effect of pressure on a system in equilibrium, we still make use of this reaction. Nitrogen molecule reacts with 3 moles of hydrogen molecule to give 2 moles of ammonia. Now, note that for effect of pressure on a system in equilibrium, pressure only affects an equilibrium involving gases. Take note of this. It only affects equilibrium involving what gases. Alright. Now, if you increase the pressure, the equilibrium will move in the direction where there are fewer molecules of gas. Whereas if you reduce or decrease the pressure, the equilibrium will move to the direction where there are more molecules of gas. Alright, so for this reaction we have here, at the left we have 4 moles of gas or 4 molecules of gas, whereas at the right we have 2 molecules of gas. This one here plus this 3 here, right? But the one is invincible. We make it 4. Okay, now if you check, we have more molecules of gas at the left than at the right. So increasing this pressure, of this system will cause the equilibrium position to shift from the left to the right, favoring the forward reaction, while decreasing the pressure of this system will cause the equilibrium position to shift or move from the right to the left, favoring the backward reaction. So decreasing the pressure will cause the equilibrium position to move or shift to the direction where there are more molecules of gas, whereas increasing it will cause the equilibrium position to shift or move in the direction where there are fewer molecules of what? Gas. Very, very important, guys. So that's it for pressure effect in a system under the Chatelier principle. Now let's write this and look at the effects of concentration. Okay, we are now looking at the effects of concentration. For the effects of concentration, we are still going to make use of this reaction. Nitrogen molecule reacts with 3 moles of hydrogen molecule to give 2 moles of ammonia. Now, for effects of concentration, note that if you increase the concentration of the reactants, the system will try to decrease by making more products, whereas if you decrease the concentration of the products, the system will try to increase again by reducing the amount of reactants. So that's the effect of concentration on equilibrium system. Okay, so if you add more of nitrogen molecule and hydrogen molecule at the left reactant side, the forward reaction will increase to produce more of ammonia. So an increase in the reactants left hand side of this system will cause the equilibrium position to shift from the left to the right, favoring the forward reaction, and vice versa. If we reduce more of the nitrogen and hydrogen molecules, the equilibrium position will shift from the right to the left, favoring the backward reaction. Okay, so this is basically how you can use the Chatelier principle to predict the effect of any change you make to a reaction system. Alright, so before we call this a class, let me give you guys this practice chemistry question under the Chatelier principle and see if you can figure it out. Let's write this. Okay, guys, now look at this chemistry practice question. It says we are asked to state the effects of an increase in pressure on the amount of products at equilibrium. Okay, so feel free to pause this video and see if we can figure this out. Remember, we are looking at pressure effects. Alright, so we are asked to state the effect of an increase in the pressure on the amounts of products at equilibrium. So give it an attempt. Okay, let's do it together. Now, as we all know, for pressure effect, it involves equilibrium of gases. Let's begin with this first reversible reaction we have here. An increase in pressure will cause the equilibrium position to shift from the right to the left, favoring the backward reaction, because at the right we have 2 moles of gas and here we have only 1 mole of gas. So it will shift from the right to the left, favoring a backward reaction. Whereas for this second reaction, an increase in pressure will not have any effect because we have 2 moles of gas at the right and we also have 2 moles of gas or 2 molecules of gas at the left as well. So this one here plus this one here, I'll give it 2, and this one here plus this one here, I'll make it 2. So there will be no effect for the second reaction. And lastly, for the third reaction, an increase in pressure will cause the equilibrium position to shift from the left to the right, favoring the forward reaction. We have 3 moles of gas here and we have 2 moles of gas here at the right. So the equilibrium position will shift from the left to the right, favoring what the forward reaction. So that will be the answers to these questions. Basically, in this first reaction, since the equilibrium position will shift from the right to the left, so more of this substance will produce nitrogen 4 oxide, whereas in the reaction 2, no effect. In reaction 3, since the equilibrium position will shift from the left to the right, so more of carbon 4 oxide or carbon dioxide will be produced. Okay, Hope you learned something interesting from this video. Now, if you are new to the channel, ensure you check the description of this video below. It's a link to our Telegram channel. Click on it and join the Telegram channel for instant notification. Also, ensure that you are subscribed to this channel by hitting the subscribe button for more videos like this. Like, share, and comment on this video. Tell me how you feel from what you learned from this class. If you seem to have any specific questions to ask regarding this topic for chemistry, feel free to leave a question in the comment section below, and I'll be sure to give you a response. Now, click on the end screen above, and I will see you in the next video. Thanks for watching.